All right. Welcome to the Audio Programmer Podcast, episode 16. It's been a little while since we've actually had a podcast, and this had this great discussion a couple weeks ago with our guest Neils Johannes de Wit, and we were talking about we need to get on camera and just have this discussion about all these cool things that we're talking about. So Niels is with me today, all the way from the Netherlands. And how are things going, Niels?
I'm doing pretty fine. Taking on different kinds of challenges these days, technically and hobby-wise, and actually, it's been a while since I've worked on for example, it's not just mine anymore. It's me and a guy called Paul, our open source synthesis engine, which we ditched a while ago for different reasons. Like we had like things going on live that included us having to generate some more money and stuff like that. So but anyway,
Mhm.
we just decided to like pick it up again, and I sent you like a standalone version of
Uh,
the JUCE behemoth, as we call it, because it's like terrible. And that's why I also told you that this guy you probably know from LinkedIn, at least, Yellow Bucker, he's gonna do
yeah.
it, talk about how to properly use value trees and stuff like that in JUCE. And that's something that we didn't really took care of. Like it exploded into kind of a hack. That's why we didn't release the VST source code yet.
Yeah.
So I'm gonna have a talk with him. But anyway, other than that, things are fine. I have actually decided to leave the company, Build a Rocket Boy.
Mm.
I will not go into why or whatever, but let's just say we ended on friendly terms.
Uh-huh.
But I'm still, at this moment, mostly doing consultancy and actually programming work in the audio space of game development, and I'm hoping to get back into synthesizer development as well, because that's where it all started. Like in 2016, 2017, I started working on hardware synthesizer.
Mhm.
So but there's a story behind that. So how much of it do you want to hear?
Well, I thought right before we went live, we were talking a little bit about our DJing background. So we both share
Hmm.
mutual DJing background.
Yeah.
Uh, and yeah, so um, we were talking about different needles. So we actually have the same, coincidentally have the same needles on our turntables, the Hubert Ortophon scratches.
Yeah.
But you were saying about how you used to have the Concords. Was it the blue ones or the black ones?
The no the yellow ones, the Club Mark twos.
Ah, yeah. Is it
Uh,
not the
I've
black with the yellow tip? Was it the black with the yellow tip?
hang on for a second.
We're gonna geek out on DJ talk for a second here. Ah, yes. Yeah.
These ones, but
Yeah.
I think they're dust magnets.
Yeah. Yeah.
So, but I've had a range of needles. I mean, in the days when I started playing records, it was just one standard needle you had, which was the Stanton 500.
Yeah. Or
But
the
that
680. Do you remember the 680? The,
oh
the thin one? I thought those looked really because the Stanton one had the little fat one, and then you had the 680, which wasn't quite as heavy. It was like thinner. It was thinner. And somebody actually in the chat talked about the. Do you remember the M447s?
yeah, by sure.
Yeah, yeah,
Yeah.
sure. M447s. Back in the day, those used to be very elusive to get. Uh, and I don't know if you remember, but you used to have to tilt. There was a certain way that you had to configure them in order to, because a lot of the back in the day when with DJs that were doing a lot of scratching like myself,
Oh,
you had to configure your your turntables in a way that where the record wouldn't skip. And with the 447s, it was like you had to angle them like slightly outside, I think, and then you had to take the weight, you had to turn it backwards. Then you had to set the height of the height of the turntable arm to I think the highest setting that it could be. Uh,
yeah.
yeah, it was good.
So it dove like directly into your record, basically.
Yeah, yeah, basically.
That's great, but that's really great for your vinyl. You know, I was never a scratch DJ. I mean, I'm Dutch, so I grew up with like gabber music and trance music,
Uh,
as a house. But eventually, I started playing disco. It's all disco, electro, all that kinds of stuff. But basically, I was just looking for a good needle with a decent output that could also, because like these Q-Birds are 11 millivolts.
mm,
And if you play at a venue and you might mix them yourself, like using of the CDJs and the and vinyl,
uh,
or someone else plays a set on CDJs and then you follow by vinyl, actually that higher output quite nicely matches it, so you don't lose. You don't have that subtle drop in how much. But we can talk for ages about setting up turntables and
yeah.
different kinds of needles. And I'm interested to hear all about it. I mean, I can see you're a scratch guy because you got them like this way.
Battle style. The turntables are battle style.
About,
Yeah,
yeah, yeah.
yeah.
I've only ever done that when I needed the space, but
Uh,
otherwise, I'm more of a mixing kind of guy.
yeah. Was DJing what got you into audio programming originally?
No, not at all. Um, I was I think about 8 years old when I told my dad that I would like to try my hand at playing the piano. And so I had piano lessons for a good while, and I'm rusty by now because it's been a while, but I can still hold my own a little bit when I play. Like for example, there's a stage piano back here and a DX7 and then all other kinds of stuff that I told my wife I bought for research purposes. Uh, so that's fun, and I've just always been intrigued by music. I remember that my dad was always very supportive in that way. In that, like when I was a young kid, I didn't get like a boombox or anything like that. He bought me an amplifier and speakers, and then a tape deck, and later on a CD player and stuff like that. And that's when it started. And the old DJing thing came because I wanted to. I was a little bit socially awkward, like most programmers are, and I wanted something to set me apart. And I thought, well, maybe DJing is a cool thing to do. And eventually, yeah, it turned out to be that way. But audio programming that came on later. I'm not sure if you're familiar with the demo scene.
I know about it. Yeah. So for people that don't know what the demo scene is, can you explain it?
Yeah, it's tough to explain, but let's
So it's
just
like
say,
small self-encapsulated programs, right? That are just designed like kind of single purposed type of apps, right?
I hope I won't get lynched for this simplistic explanation, but let's not make it this too long. Um, like back in the days, games were hard to come by, and there were cracks for them to get past copy protection, and there were things called trainers where you could actually modify certain parameters within the game that made it easier or harder to play or whatever you wanted. And at a certain point, people started pretty much like in the graffiti scenes, tagging them, you know, with their own thing, and that's what spawned something called the crack throw, which groups like Racer 911 and stuff like that are very famous for. And over time, and then we're talking like mid to late 80s, might be a little bit earlier, but I think around that time, people started to turn that into an art form by all by itself. So what happened is that like someone who could make music and someone who could code graphical effects and someone who could like pixel graphics, they came together. And this is a very basic explanation. And over time, that developed into a scene where like full productions were made of different types with different restrictions. Like this can be like, for example, a 40 kilobytes maximum executable all in on an Amiga 1200 or a 500, or a 64 kilobyte, or which is still a thing, like many other categories on a PC. And we started competing and having our own scene basically, and that ran way out of hand to the point where like last year or no, not last year, last spring, after a 9-year hiatus, I came back with a software rendering based demo at a party called, or a convention really, called Revision, which is held in Germany. And I'm not sure what the attendance number was, but it must be 700 people or more at least. And yeah, and that's been going on for a long while now. And I've always had a certain appreciation for the audio part of it. Um, in the past, and I'm just going to into my past because I don't feel at liberty to talk too much about like all the more old school platforms that I don't know everything about. But let's just say on PC, like when I started in that scene, that was like 94, 95. On PC, we used software like Fast Tracker, impulse tracker. We use track modules basically to yeah, to have musicians track our music. And actually we even used like those track signals to sync. And that's basically how it worked. And let's say that for a full demo in which there was a, back then there was like a size limit, like 4 megabytes or 8 megabytes or 10, 12, whatever. And right now it's like sometimes people go over a gigabyte. But for example, for a 64 kilobyte intro, what people would do is they would take like a track module and they would rip out the samples out of the file itself and then compress that, and then at runtime calculate these samples again using software synthesis, just basic DSP, and then blow the file up again in memory and then just feed it to a module player that was also usually stripped down to the bones just to fit into that size frame. So we got kind of creative with it, and I never really got into it all that much because I my focus was on graphics programming back then, and some systems programming, which eventually landed me up in the game industry. But I always wanted to. I always had a soft spot for AdLib, you know, the AdLib card, so the basic FM music, which was widely used as well in crack intros that were still there and are still there on PC. And I think it was around 2016 or 17 or maybe even 18 that I decided, all right, I'm gonna have another go at making an AdLib player. And that started out with simply just, well, what do you do when you start from scratch? What I did is just render a sine wave, yeah, to a raw wave file and then just play it. And it's like, all right, I hear a sine at this certain frequency, and that's fine. And that grew out to be a project where I wrote a simple on Windows back then audio output device. I'm not sure if it was direct audio or wave out, but it doesn't really matter. It's a detail. And then later on, I did the same thing to grab MIDI input from devices that I could attach to my system. And then we're talking things like these.
Mm-hmm.
So in the beginning, I had these cheap M audio stuff, which was great, by the way. In any case, at a certain point, I got to a point where I could just play notes, just pure sine waves, and started to figure out, okay, so now the next step is to work this towards frequency modulation, or actually it's phase modulation, as you know. And that's where the journey started. It took me a long while before I made the decision to transition to JUCE. And just to make it clear, we only purely use JUCE as a front end thing. So we would plug in our own audio engine, Bison, for example, which was written in completely standard C++. I think the standard is 14 that you need to compile it by now. And it has a basic API like note on, note off, reset sample rate, etc. And basically all you do is you modify a patch on the fly, and it was always supposed to felt like an instrument that you could play. And yeah, what's funny is that, or funny, frustrating and funny, but I think eventually everyone goes through that process. I made every mistake in the book when it came to audio coding. For example, something that's now very obvious to me, at least, is that temporarily interpolating your parameters, for example, and not basing it purely on sample rate. Even such simple things were not obvious to me. I had to make all these mistakes, and I had to learn what a transient is. I had to learn what aliasing is. I had to learn how different oscillators work, and how you mix your samples. And one thing that I fought a lot with is, especially because Bison is, like I said, supposed to be an instrument as well, is like a polyphonic input algorithm. And I wasn't done with just that. Like I wanted to have that working well, but then I wanted to have monophonic as well. And so you could switch. And then when you work with monophonic, you get to work with things like glide and all those kinds of parameters. And then there's more. There's filter theory, of course. So then we're diving into what I feel still is the little bit more complex DSP. So I had to learn about, like, all right, so what's like a basic 6 dB slope filter, and that kind of happened to have a lot of parallels with, like, for example, a simple blur in the graphics world. Basically, one of those, like a low pass filter is basically what a blur is in graphics world. So that made it easier for me to understand on some level, to have that background. But I should be honest, I used a lot of public domain code, especially in the beginning, because you can't slay the elephant in one turn, so to speak. So you have to make peace with the fact that there's just some stuff you don't really completely understand yet. And then there's luckily a very lively community. There always was. Let's just start with music DSP, but there's much more. And there's just like some well-explained code there that you can adapt and put into your synthesizer. And then as you go, as I went, um, I learned like the peculiarities of certain filter types, and um, I learned how to use them and also how to modify them. And through modifying them, I learned how they worked to a certain degree. I mean, this is a learning phase for me still after all these years, but I learned how they work through having certain demands that were outside of what they were written for in the first place. Um, and I was always curious. I never stopped. So this synthesizer that we put together, it can do a lot of things. Like it has 6 operators, and you can use these operators all as carriers, which basically is just a stacking of yeah, oscillators and stuff. I had to learn what an envelope is and how to what kind of different types of envelopes there are and what kind of characteristics they have. Um, and yeah, there's just it's I could like go on and on and on, but basically building a Bison, which is far from perfect, and that's why we're trying to go and find some time to pick it up again and like polish a little bit more. Has been my entry into audio programming, and it's put me in an interesting position. That and that's no knock on anyone, but especially in the game industry, my my experience is that the knowledge that you build up when you're like doing real actual synthesis gives you a background in DSP that is much stronger than people usually come with in these types of jobs. And combining that with the fact that I had a background or have actually in graphics programming, including like all kinds of linear algebra because I used to do ray tracing, ray marching, but also like uh, traditional 2D effects and polygon rendering, and you go on. But combining especially the 3D math and what I knew about DSP and filtering, that made for an excellent combination to enhance game sound in the spatial audio area mostly. Mm-hmm. So to give you do you have any questions up until now, or should I continue?
I have loads of questions. So one of the things, going back to what you were describing earlier with the demo scene, so that sounds similar to me to the shader scene. Is that right? So the way that
there's a huge overlap. Yeah, you could argue that a shader isn't necessarily just a GPU program. A shader is a very wide concept. It's just a rendering algorithm, basically. So yeah, that's absolutely like yeah. Mm-hmm. There's an absolute overlap in those scenes, and we also have competitions in like shader coding where 2 people sit in front of each other and they have 25 minutes from scratch. I competed in that myself as well, not too successfully because I'm an old man, but but I did it anyway. So yeah, that's definitely a good parallel.
Yeah, very interesting. And so what what are you trying to do in that time? So you have two developers facing each other. Is it about who can create the most interesting um, visualization with the least data? With how do you know who's the winner and who's the loser? Do you have a
Oh,
panel of
it's
judges? How does that work?
it's first of all, I don't feel that there's ever a loser, because it's quite it's quite daunting just to step on a stage with a lot of people in front of you, and facing someone else who has like the same starting point. We created our own software, or we have our own software to facilitate these competitions. But anyway, um, it's basically a pissing contest to the point where who can make the prettiest thing. And after, depending on the rule set, sometimes you can use data, sometimes you can use no data at all, and it's fully procedural. But it's like a pissing contest, and then at the end, someone gets, like the audience gets to decide like who wins that round, and then you can proceed around or whatever. And sometimes you have these things called super fights, where it's just like a one sort of known person versus the other. And so it's a fun thing to do. And it's become a very prominent and yeah, important part of the demo scene as well.
Cool. So another question that I had was that you had described your open source synth FM Bison, and the way that you handled it was you actually handled the DSP and the audio, the audio part of the stack using standard C++, and that you used JUCE for the UI layer. In my experience, I've found that a lot of people actually do the reverse, which is that they try to use JUCE for the abstraction layer for the audio, for audio, and that they try to match it with a different type of UI layer, or UI library. So I'm curious about what led to that decision, especially with you coming from a graphics background.
Um, okay, that's an interesting question. I've always been interested in doing things myself. Um, so let's say that, like, my motive to like pick audio programming up as a serious thing was never financially backed. That was not the thing I had in mind. I wanted to learn how it actually worked. And I think there are different kinds of mindsets when it comes to building audio plugins, and audio software in general, or any kind of software basically. And I mean, I always wanted to have I always wanted to be the technician. And that doesn't just apply to audio. That I did the same thing with graphics and systems programming. And I also have a quite strong pedigree in optimization for, like, for example, SIMD instructions on different types of CPUs and stuff like that. And yeah, memory optimization. You go ahead. But that's what interests me. And that's why I didn't even know or think about JUCE before it all started. Like I said, the first thing I did was just render a sine wave to a raw wave file and just listen to it. So, okay, that sounds right. And then go from there. And what I thought, and I must say before that, I worked on at least one synthesizer I can talk about because it's been out for a while. It's called the Tasty Chips GR1 granular synthesizer. And I helped set up some like OS code and some yeah, sample mixing code and stuff like that. And that was actually my first exposure to audio coding, and that made it more interesting for me as well to pursue later on. But for me, building a UI was never my groove. That was never my thing. I don't like it all that much, and that's why I'm very grateful that a guy called Paul Copes, uh, who I worked together with for a long while, and hopefully we're restarting that venture again. He came in and had a lot of good ideas about that, which helped me out a lot. But I was always about, all right, I want a standalone sound engine that I can basically plug into anywhere. And like the reason not to optimize it with specific machine code instructions was and still is that it's fast enough
Mhm.
as it is, and it's just very convenient to be able to compile on different platforms however you want. And yeah, I fully understand why people, for example, pick JUCE also to facilitate them in their DSP needs, because it does have a lot of primitives in there that are very well crafted and useful. But for me, um, yeah, I wanted to make an instrument. Yes,
Mhm.
that's true. But I also had this deep seated feeling that I wanted to learn how things work. And like I said before, I'm still far from done there, but at least I'm now at the point where I understand quite a bit about like how do filters work and what are the different specifications and pros and cons and I like to build my own DSP. Well, let's just call it crap. For example, um, I built like at some point I wanted to have an auto wah filter, and I was like, okay, now how does that work? And that started a whole new addiction, buying guitar pedals. But I built something on my own, and it has this ghosting effect that you can enable. So you can steer it with the pedal, and there's also like a vocoder that you can like blend in there, which you can set to a fixed vowel frequency, or you can enable sample and hold, all that kind of stuff. It's just that kind of stuff interests me. I want to know how it works, and knowing how it works has also enabled me to build things outside of the realm of synthesis per se. And then we're going to games that are let's just put it this way. It's easy if you have someone on your audio team who knows how to do the digital signal processing part of it and modify it to see it fit like the like in terms of what we need, instead of using ready set plugins for everything. Um, yeah, it's just a whole lot of words to say. I'm interested in knowing how things work from the ground up. Always have been.
So we were talking earlier about how one of the items you wanted to discuss was just common traits or common uh, mistakes that you've seen other developers make along the way in their journey that you've learned from. So would you say that curiosity is one of those essential traits of a good software developer or a good audio programmer?
I think it's regardless if it's an audio program or any other specialization. I don't feel it's my position to say what what's good and what's right and what's not. I don't feel I'm in position to judge that, but I do feel that you do need people who have a certain deep-seated curiosity about how things work, who aren't satisfied with, all right, we have this class, I know how the interface works, I know more or less what kind of results I'm going to get out of it, and that's it. Um, that only gets you so far. Um, that's basically how I look at it.
What are some other things that that you've seen through your travels? What are some lessons that you've learned in terms of how you become a successful developer and successful in software development?
In general,
Yeah, just for you.
okay. Well, first of all, I would say that considering yourself successful is not the best thing to do at any point. What I've learned is that, at least for me, there were a couple of stages. Um, there's like the beginner stage where you're lost and you're constantly searching for information, and every small win seems like a huge leap. Then you get to this novice stage where I at least thought I knew everything, and then like, and we're talking about like 20, 15 years ago, where I used to work on titles like Tomb Raider and a little bit of Killzone and some other AAA stuff. And I make the flaw that a lot of people make in thinking that, all right, I get this down now. But as far as I progressed, I started to realize that the further I get in programming in general, the more I realize that there is so much I don't know. And especially these days where like just not like the whole range of how, where and how we apply software has grown, like not just exponentially, but so much more, that there are so many specialisms that it's just hard to be you shouldn't get complacent at any point in time. That's the way I look at it, and the same goes for audio programming. One thing about audio programming though is that what I noticed, especially on one team in at a Swedish developer I worked for a couple of years ago. I worked for them for 2.5 years, I think. Is that having someone who comes from a different angle but still has like a good amount of technical knowledge. So let's say they call it a sound designer or audio engineer or whatever, is so useful, because like all these different kinds of trades that touch on different subjects within the audio realm, if you get to work with these people, it enriches the way you think about things, and it gives you a lot more space for nuance, and again, and also for humility, like knowing that, all right, I might know how to build a very cool sounding supersaw oscillator, but on the other hand, if I'm talking to someone, a colleague of mine, and we're talking about a spatial audio plugin that basically, for example, generates the idea of reflecting gunshots on geometry that's close by, these people may come with ideas that I didn't think about at all, and vice versa, and so you gotta work together, and that goes for programming in general, but in the audio world I think it's especially important that like we bundle our strengths, and that it's not a pissing contest in a way that like oh yeah, I know DSP, so I'm gonna tell you how everything should work. No, 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 no. It should be that everyone from every angle has their opinion, and there's an open and free discussion about how you're going to tackle certain problems. And only when you do it that way, like with real teamwork, you're going to get to very interesting solutions.
Mhm. Yeah, that was one thing that I was curious about, especially in the game scene, is that you have all of these different things that have to come together. You have dialogue, you have somebody that's writing a story, you have somebody that's probably doing some 3D rendering with creating characters, creating scenes. You have yourself in audio. What does that look like in terms of your day-to-day workflow? Are there a lot of meetings, or how much development time do you normally have per day? How does that get coordinated? Especially, I imagine that you have multiple teams in different countries trying to come together on a mutual code base. How do you manage all of that?
that's a complex question. I'll try to answer it as best I can. So the past, and that's the time span I can speak for, the past 20 to 23 years, things have changed a lot and things have gotten a lot more complex. Um, so yes, there are teams at most companies, and then we look indeed at things like rendering, we look at gameplay, physics, audio, generalist. We look at porting and compatibility for different kinds of platforms. Like, for example, a lot of AAA titles are shipped for not only PC or Xbox, but unless they're like have an exclusive deal, they're also shipped for PlayStation, and you have what have you. So there's a lot of moving parts there. So depending on where you sit within the company and how the company is structured, there's more and less time that you spend on actual programming as a programmer. So um, we do generally facilitate two trajectories that you can go in, and that doesn't just apply to programming, that applies to art and stuff as well. You can go the what I call the managerial route. So that basically means that let's say you start as a junior, you become a meteor, you become a senior, you become a lead and a director. You can go the other way, and then after meteor, become a senior, and then you become, for example, a principal. And the difference is that on the left side of things, you are mostly kept busy with tackling technical problems. And on the right side of things, you mostly get into the decision making part of things the further your career develops. It depends really per company how they handle that. And it also depends on who you are with and how you profile yourself within a company. If you have opinions about things and you know how to, in a respectful way and in a clear way, voice them, you are more likely to be involved in meetings that are cross-disciplinary, so to speak. Because yeah, of course, like an animation team, for example, needs to coordinate with an audio team. Like, how are we going to do simple things like lip sync, stuff like that, because we need that data from A to B and from B to A. Luckily, there is a lot of middleware these days, a lot more than there used to be. And you must be familiar with middleware like Fmod or Wise. And sure, we all have our opinions about these software packages, and they vary among teams and persons. But like a package like Wise does add a lot of functionality that would be an enormous task to put together if you're building a big project. And it gives an enormous amount of freedom, actually, that you can have exist between the audio designers and the programmers themselves. So it's not really cut and dry, like who does what and who gets to say what. It also depends on the size of the company. So like, let's say you have a AAA studio with 250 people or 500 people or even more. There tends to be more hierarchy, which you have to deal with. And you can either like that or not. I don't so much personally. And at smaller companies, these lines are shorter, which I find more fun because it makes for a more dynamic way of developing, and at times I feel, at least, it allows you to express your creativity a little bit more, because there's just less bureaucracy, and that bureaucracy is necessary within a big company. Don't get me wrong. I mean, you can't run a 60 people development team the same way you do a 500 people team, of course. So do I answer any part of that question, or do you want to know a little bit more specifics?
Oh, I have a lot more questions. So tell me about in game audio programming. what is the programming aspect of that? What are you doing? Are you creating DSP algorithms? Are you what is it that is the actual game audio, the audio programming part of game audio programming for you?
That that
I
that
know that varies between different companies, but in your experience, what does that look like?
In my personal experience, there are people who are very well skilled. They sort of seem to have this proper balance within themselves between understanding audio programming and gameplay programming. So they are very well suited to gap that bridge, so to speak. And for example, the role that I usually had or have is more towards, okay, we need to design, for example, a spatial audio plugin. And I mean, I can't talk too much about this, and you know why. I mean, every company I've worked for, I have to sign an NDA. So
Yeah.
if I'm going to tell you about specifics, I'm going to be in trouble. But let's just give you a very simple example. Let's just say you have a level of some sorts. And in this level, there are certain static sound sources and there are dynamic sound sources. And these sources, your dynamic sound sources are spawned during gameplay, and the static ones are, let's for example, there's a diesel truck running somewhere outside a building, and there's a corridor next to it. And the player had walked through the corridor and went into like another room that's attached to the corridor. How's that going to sound? Well, there are a few ways to go about that, and but it basically all comes down to that you make a spatial reconstruction that's like to a certain level of detail, a attainable level, achievable, attainable level of detail, and then you basically like, for example, do ray tracing to cast rays until you reach the player more or less, and every time this ray hits something, you're going to calculate, all right, so okay, at what angle did it hit it, what kind of material is this like shag carpet or is it metal, and that is all kind of information that goes along with the next cast and until you reach the player. And when you've reached the player, you've sort of calculated how the sound has been uh, performed by either filter banks, reverberation, dampening, you name it, different kind of DSP algorithms. And you use the whole team to get to a solution that works for your game. And that's quite tough because like everyone has an opinion about that. And what I found quite useful over time is to um, take people from different disciplines within your company and just put a good pair of earphones on their head, or just put them like in a room with proper dampening and good monitors, and like, how do you feel, like does this feel natural? um, these are the kinds of problem that you tackle together. And where I would usually sit is on the point of okay, so more of the DSP kind of thing. Like I need to like okay, so this is a shag carpet reflecting, so I need to apply a certain amount of low pass filtering, for example, or I need to modify the trail of my reverberation, stuff like that. And what I've experienced is that, and that makes, I think, audio programming in games, certainly because it's relatively, well, not relatively new. That might be overstating it, but it's not all that long ago where audio in games was a matter of playing music, and if you hit something, play sound, and that was it, and that was all mixed kind of equally, and that, you know, PlayStation 1 style. And now we've come to a point where we want to approach realism a little bit more, and it gets hard. It's hard to get like proper feedback because what I've noticed is that, especially in like internal or external play game tests, if something sounds right, um, people won't be able to tell you why or anything like that, especially if they're not like they don't have a specific background in audio or something. But you're gonna hear about it if it's wrong. So it's like a curve that goes this way. You go from wrong to okay, and then it goes like output wise and input wise, like in the way that test teams and co-workers respond. Basically, at a certain point, I've been quoted to say like if and excuse my language, but if nobody's bitching about it, we're doing a good job. But definitely, if you do it wrong or wrong, if there are bugs here and there, or there's like especially there's latency or like transient artifacts or stuff like that, or pitching or like things that definitely like spatial audio definitely seems to come from the wrong direction, you're gonna hear about it. But when you and that sometimes is frustrating when you really put some time into improving something and trying to make it sound better, and you have like the overall with your co-sound developers at a company, like, all right, we've done something awesome. You're not going to get like a lot of applause for it usually because people just take it for granted that it sounds okay. And that's been an interesting experience for me, like when, like, for example, when you graphically enhance something, um the eye seems to be a more coarse instrument of observation to me than the ear is. And you might or may not agree, but I think you do. You can hear like the slightest variance or error in a floating point stream. Whereas if there's like a little flicker between two pixels, there's a very tough chance that someone picks it up, especially during immersive gameplay. But anyway, so that's frustrating at first, but then you know, after you accept that you're kind of in your own niche, it's okay, and I find it's a very gratifying process to work with skilled audio people, in different fields of the programming field. So, like I said, like the audio designers, the technical audio designers who also usually have a background in DSP, not seldom the university guys. Then we have the guys who bridge the gap between gameplay and audio, and then we have like the visionaries, who have ideas how things should sound, and like, all right, so go run with that and try to make that. So yeah, and audio people are fun to work with in general.
One question I had was about when you were talking about testing, and I'm sure that there's variance in how this works through different companies, but when you have external testers, do you tell them specifically that you want them to key in on the audio, or do you ask them specifically about that, or do you kind of leave it open and say, well, just here's the game, tell me what you think? How does that work?
That very much depends on the situation. If there's a clear problem, then sure, yes, you're going to deliver a build, and that build is going to be tested. And among the things that are usually listed that people have to take into account when both experiencing and listening and watching, that would be one of the things they have to look out for. But there are also situations um, where you improve something. For example, you improve something drastically, or at least you think it's drastic. That's actually not up to you to decide. I mean, because as an audio programmer, you're very biased usually, or audio developer in general. But then you just put it out there, and then you check like, is someone noticing something? And you might ask questions. after the test, or you might make some recordings to yeah, have people, give them some material to compare it from how it was and how it is. That's very context specific. But yes, of course, if there's something wrong, we want to know if it's right. If we improve something, it's it could be a different call that we make every time. Like, are we going to tell them beforehand? Because if we tell them beforehand, the danger is that they're going to take it for granted, that their bias shifts even before they've heard it. Like, okay, so yeah, I find it hard to explain, but I hope that you understand what I mean. Is
Yeah.
that you create an expectation, and by creating that expectation, the amount of feedback that you receive is potentially a much lower than you would get if you don't tell anybody anything and ask afterwards, like, how was the audio like? And even then, I mean, like I said, audio is such a natural thing for people, that it's hard for them. It's hard for me, but it's hard for the generic gamer or anyone basically to say like, oh well, this was much greater than it was before or whatever. So one tool that we do use, to demonstrate like, what to listen for if we make, for example, a spatial audio. There you go. In, but that's all the hype these days. But a spatial audio thing, that has seen some improvement. We render two videos of two scenarios, and say, okay, let's listen to video A first, and then listen to B, then now go play and see if you experience the same kind of step up that we are trying to achieve here. So especially because it's, like I said, it's not relatively new, but it's like graphics programming has a way of much of a more of a leg up in terms of being scrutinized than audio programming, which means that, yeah, we're still trying to figure out like what the best way is to have this tested, except with our own ears, which aren't always the best because, yeah, of course, when you're working on something yourself, you do tend to get biased as well.
Mhm. What about game audio programming versus what you've been doing with pro audio, making a synthesizer, making a VST instrument? Do you find, I imagine, I mean, I would imagine that it sounds like the stack that you need to work with in the game audio world is so complex. And then coming over to the pro audio side and building a synthesizer, well, you know that 9 times out of 10, that's going to be a stereo setup. So you only have to worry about two speakers. Most, the graphic layout, you have limitations there for the most part. So, I mean, I would imagine without trying to underestimate pro audio, but I imagine it must be like a playground for you coming from the game audio world to doing a synthesizer when you have to build for two operating systems. You have a number of dollars to build for and everything. But do you find that it's easier, or do you find that it's just that the challenges are different?
Well, like you correctly put it, especially nowadays, the stack is much huger when you're looking at a game project, especially a bigger or a more ambitious game project. And let's just draw a line here with, building a synthesizer is one thing, but building audio for a AAA video game is more and more like designing audio for a Hollywood movie. So there's much more things at play. I wouldn't want to go as far as saying that one is easier than the other. I mean, not for nothing. There's a lack of people who know their DSP in game development. because usually those people gravitate towards synthesis and building guitar pedals and you know all that kind of stuff. So that's just they're more they're more liable to end up at native instruments rather than electronic arts, to put it that way. But yeah, you're right. I wouldn't say that either one is necessarily easy. I mean, the theory behind building like a good synthesizer and the creativity that comes along with it, it's just a completely different ballgame. Whereas in games, yeah, you're dealing with something that's very much more akin to yeah, designing and creating an audio stack that's comparable with movie audio and stuff like that. Because let's face it, especially modern games with a big budget, they are becoming more and more like an interactive movie all the time. So that's what you're looking at. And yeah, sure, you could argue that making synthesizers is easier. I personally, as a programmer, think they're just two completely different things and they can't necessarily be compared. And I also think that knowing about both is a very useful thing for a programmer working in either.
And what about, so one thing that I've been curious about lately is just musical interaction, the way that we interact with instruments, the way that we create music. It's been more or less quite static for the past 20 years, in terms of the interfaces that we have, the way that we interact with audio and the way that we record audio now. Do you have ideas or frustrations or ambitions in terms of where you would like to see the pro audio side go in terms of synthesizers, musical instruments, software musical instruments, where and the way that we interact with those, the interfaces that we have? Where would you like to go? Because for me, I feel like if we look, it takes so much work to make a compelling software instrument in comparison with, you look at the things that you can get out of the box with like Unreal Engine, for instance, where you can have 3D landscape with very compelling graphics quite quickly. So I'm just curious in terms of the interface part and in terms of the way that we actually interact with these instruments. Where do you see that going? And do you see that there are ways that we can bridge the interactions between how we make music with how we play games? I know that was probably about 5 questions in one, but
yeah, that's quite a question. Let's see. So first of all,
because there are some people that say the way that we make music, the way that we make music and the way that we create music now is good. The interfaces, I want to have them as knobs or as sliders, and that everything else outside of that is a distraction. That if we got more complex in terms of the graphics capability and what we could do there, that those would be more of a distraction and get away from what we're actually doing, which is creating music. Whereas from my perspective, I feel like maybe it's time for us to think a little bit more outside the box.
I think that let's just for example tie into the whole. Let me ask you a question, just a short one. I see a pair of turntables there.
Yeah.
I got a pair too. Why do you have them? Short answer, please.
The control. It's about the control.
Because you love it, right?
Yeah, because I love it, and for me, there's this interaction that happens between between you and the music through your hand and the way that you're moving it that is where you're actually taking something and you're creating something else with it. You're creating a new, well, you know, for me as a turntablist, as a DJ that was doing beat juggling and scratching, that it was about taking sounds that were already composed and kind of taking them into another dimension where they're becoming new compositions, they're becoming something brand new. And to me, that is extremely exciting. But yeah, it is about love. Yeah.
So what you just said, I think is the most important thing. And by the way, I've always been very impressed with turntablism. I mean, I love to mix, and I've done it for a long time. But that's a completely different thing. And turntablism is just awesome. But having said that, so that's something you love to do, and how you love to do it. And the same goes for me. And certainly in these days where people use CDJs and stuff like that, people have a certain love for the way they express themselves, and that can be tactile, like turntables or a guitar or a piano or whatever. Um, and I feel that yeah, there's a lot of room for improvement in in synthesis, in like software synthesizers and stuff like that. And I mean, I think that like this little thing here is a good example of trying to take it a little bit further. I'm not necessarily one for yeah, I'm quite of a traditional guy when it comes to all kind of that kind of stuff. But I think that there's just a lot of ground that's still uncovered, and that goes both ways. However, I do feel that it sometimes feels like we're hitting a bit of a ceiling when it comes to yeah, making instruments as in synthesizers. Uh, I mean, they're still making roads, new ones, you know. I mean, what's that about? Wasn't the Mark II good enough? So you see my point. And as in game audio, that whole process of coming from literally calling a function called play sound to where we are now, that process is far from done. There's so much going on, and there's just like so much new techniques, and people are like creatively thinking out of the box, like how can we spatialize our audio better, and how can we mix these things together in a more immersive way, and also on a design, from a design point of view, which is absolutely not my wheelhouse, but like game designers taking audio much less as a static thing, but like considering as something that they can use much like a tool like animation or graphics or gameplay that plays on an equal, or if not like more sophisticated level than it ever used to be. So like that journey is far from over. So I think that in game development, and not just game development, but also probably movies and other kinds of multimedia applications like art installations and what have you. There's a lot of ground to uncover. And as for synthesizers, I think it has been stalling a little bit for a while in how we do things. I think that's also why I'm not sure. I just like the name just dropped out of my head, but this, like, apart from JUCE, the creators of JUCE started creating this new, like, more scripting oriented language. Do you happen to know what it's called?
C major. Yeah.
So like we're moving in different directions, and um, like for example, like a small MPE capable device like this it's like the new theremin. So I don't think we'll get to a standstill at all, though there is a certain I think that in music there is a certain love for tradition.
Mhm.
Um, I wouldn't be surprised if people are still playing pianos in a couple hundred years.
Yeah.
And does that mean
What about the way that we're experiencing music? The way that the way that customers, the way that people um, interact with music as a finished medium. Where do you think that's going?
um, I think that potentially artificial intelligence will start to play a bigger role.
Mhm.
I mean, it already does in a very simple way. For example, let's just say that not just YouTube, but all kinds of other platforms anticipate what you might want to hear next.
Right.
I can see that taking a leap forward and forward and forward and forward over the coming decades. Um, we might arrive at a point somewhere where at some point where like generative audio is like tailored to you as a person. I don't know. You can have the wildest ideas about that, but I don't know where to go. I mean, I like my traditional music just fine. But I'm open to all kinds of suggestions. But if I may just speak for games, yeah, there's still a lot of uncovered ground, and I see that going forward in huge leaps over the coming decades, at least.
Mhm.
And that's going to be very interesting because it's going to like make that stack you spoke about even larger, and it's going to ask for bigger teams because especially in the past, audio teams are small and underfunded. Luckily, that's being corrected as we speak. But yeah, there's just a lot of uncovered ground. And in terms of instruments, I'm not the right guy to ask that question. I don't know. I mean, of course, there's going to be all kinds of different improvements, but if
But for you
we're
as a music maker, do you feel content with how things are, or do you feel like have you ever had a feeling like, oh, they're doing this cool thing in the games world. I wish that we could inject some of that interaction into the way that we make music.
yes, um, first of all, let me just set one thing straight. I don't produce music myself. I know how to play and then play records, but I'm not like a composer. But having said that, yes, I think actually that some techniques we're applying in games these days and that we're developing further and further, um, that they may have in a certain, maybe modified, but in a certain way, it might have their place in a synthesizer. Like you could, like for example, to think of a simple example, a sort of input device that ties into spatial audio. Just to think of something, just to spitballing here, but yeah, that there has to be a point where we're going to branch off from the classic idea of a synthesizer, which is how well we have monophonic, polyphonic, couple of filters, couple of oscillators, and all that kind of stuff. I mean, there's only so many oscillators that we can actually use in the end, I think. So there's going to be a movement that's going to be working towards a more innovative way of making music. And how that's going to look, I don't know. I also truly believe that there's that it's also partially up to the musicians themselves and not so much even like the instruments. For example, I played at a festival this summer, and there was a band before me. They're called Brass Rave Unit, and I was kind of surprised because they used like old school classic instruments like saxophones and horns and stuff like that. Together with guitar pedals, drum machines, and they basically made like this very tough rave slash house music, but with completely unconventional way of doing it and unconventional instruments. I've never seen anything like that before or heard it, and it was a huge hit. So there's like a couple of ways to go. You can look like to the right side and say, okay, we need to improve technically, or we need to like come up with different input devices and different ways of rendering sound and all that kind of stuff. Or we can like look at what we have and use it in a different way.
Yeah, I love that. I love that. So this Tuesday you're going to be presenting at our audio programmer meetup.
Yeah.
About your FM synth Bison. So like you were saying before, it's a little bit of a different synth in that the audio stack, the underlying audio stack is something that you've done using just the standard language, and you've used JUCE for graphics. So I'm really excited to see how that works, and it's a open source synth as well, right?
Yes, it is. The entire synthesis engine, which is pretty well documented as well. Well documented is in like the interfaces are quite straightforward, and there's like, let's just say I have a pretty clear and well readable code style. At least that's something my coworkers can agree on. Anyway, yeah, that's up for grabs. And I have to say before Tuesday that it is a Frankenstein synthesizer. It completely grew out of hand. Well, not completely, but like let's just say that it was a project that helped me learn about different things, and we just went completely wild with it. So I'm going to be excited to show what I can do. And I'm going to ask my friend if he can prepare some more patches for it, so I can demonstrate a little bit more, because I'm not the greatest patch designer there is, absolutely not. But yeah, I will have something to tell about it. And I think the interesting thing about the synthesizer is that it's quite fast. Because there's, well, yeah, sure, it can do a lot of things, but everything it does the memory footprint isn't that big, so there aren't that many cache issues and so forth. But it can do a whole lot of different things, and it was in as opposed to many synth DSP plugins I've seen, it was first of all meant to be a playable instrument, and it grew beyond that. But on Tuesday, you'll see what I mean. It was really like trying to make a DX7 on steroids, and we went from there.
And in terms of the formats that you're building for, is it VST only? Because I know you said there's standalone. You sent me the standalone.
What I sent you was a standalone build, yes, and that's because I knew you have a Mac, and I knew that one works. But yeah, it compiles as a standalone. It compiles as an audio unit, a VST3, both for Windows. There is Linux support, but it's not been tested all that well. But Mac is completely fine as well. And that's also part of the reason that I prefer to keep as much of it in just the standard well-written C++, because that makes it easier to compile it on all kinds of different platforms. Like the engine itself, for example, it wouldn't be too hard to compile it for a Raspberry Pi or what have you, or any kind of embedded, anything that just has a decent C++ compiler will suffice. and it renders to a buffer. And what you do with that buffer is you can write it to a file, you can output it with using ALSA to a device or direct sound or what have it. You can That was the whole idea behind it, to keep the guts of the thing apart from the output, and that also enables us to, and that's something we want to do in the future, put like smaller plugins that are really purpose built. Like, okay, we want like a certain type of sound that's very specific, but we want to do it really well, and then we're going to use just a subset of the engine. And that's very well possible because there's also kind of a layer of optimization in there that if you don't use certain features or layers and stuff, they're not processed either. So it has a good degree of scalability, but more about it on Tuesday.
And did you write an abstraction layer that builds for all formats at once, or do you have to build those formats separately as targets? How did you handle that?
Oh, that's very simple to answer. For now, we just use JUCE to do that. So we have Producer, and we create projects in that, and then we output project files for Xcode or Visual Studio or what have you. And if it comes to, for example, embedded platforms, then it's different. But it's very easy to compile the core engine for any C++ compatible compiler that's semi modern.
So you're saying that the core engine itself is also in JUCE itself, and that you didn't work with the audio unit and VST SDK individually. Is that right?
No, we've done that through JUCE.
Okay, cool, very interesting.
And that's I think one of the things that attract me to JUCE. I mean, I'm not the biggest fan of JUCE, and I'm not going to go too deep into that, but I think it's a little bit, yeah, it's not the kind of C++ I'd write, but it takes away so many work and so many sorrows from the development process that you can actually focus on what you actually really want to do, be it making your own core sound DSP processing unit, like we did, or you build a plugin using use DSP stuff. Whatever you want to do, uses JUCE just takes away, JUCE just spares you a lot of work, and it does it really well. And that's the way we're doing it right now. And if we ever want to use these AU or audio unit or VST SDKs ourselves, we can, or whatever you have. But for now, it's JUCE that basically made our lives a lot easier. Yes, absolutely.
Yeah, big shout out to the JUCE team standing on shoulders of giants there. Yeah. So it's really the DSP that is standard, that uses just the standard library. And the synthesizer classes themselves.
All the synthesis is done by us.
Yeah, cool. So let's talk a little bit about, you were saying that the style that JUCE is made in and your style are slightly different, and I'm curious about that. As a person that comes, most of my C++ experience has been in JUCE, and I know that it abstracts out so much, and it does this great job of kind of getting rid of the sharper edges of the language. So tell me a little bit more about your style and how that is different from how JUCE was created. Because I know JUCE, it tends to lead you towards this like kind of all-encompassing solution that has a specific type of workflow, which I personally love. I love one thing that I can just bring up and it's like an all-in-one solution. And I'm curious to hear more about your style and just your style of writing C++ and how that might be different to the way that the JUCE team have handled that.
Okay. So I think that ties in a little bit to my journey as a programmer over the decades. I tend towards to lean towards the philosophy that the less code you write, um, the better it is. Um, there's there's no over engineering, or there's less over engineering. There's never no over engineering. There's less over engineering. There is less likelihood for bugs. It's much easier to change something that hasn't been set in stone all too much, as opposed to something that has. And if you when you're introducing all kinds of layers of abstraction, there's, well, obviously there are performance implications to that, but let's just put those aside for now, because that's not the most important thing. The most important thing to me is that um, it isn't always very straightforward to figure out in JUCE how things work and how they tie in together. And that might also have something to do with me, like
Hmm.
because my style in programming is different. Actually, I'm also quite fond of some projects that I've recently done, like demo scene projects and stuff like that, hardly have any sophisticated C++ constructs in them. They're mostly C actually. And that doesn't mean that I think that that's an all-encompassing solution for every software project, but every project has its own demands, and I think that JUICE um, kind of uh, became a little bit yeah, there's a word for this in English, but it slipped my mind for a moment. But let's just say that I think that it became it became a little bit of a monstrosity in a way, a well-functioning monstrosity nonetheless. But there's just so much code and so much classes, and everything inherits from each from the other thing, and so forth. And to the programmer who actually wants to understand what's going on, and what kind of implications it has to use certain objects, and who isn't too keen on copy pasting code and just accepting that it works, or reading through multiple pages of manuals, or googling yourself silly, that might not be the type of code that you prefer to look at.
Hmm.
But there are different schools of thought here, and I am definitely not. I am a huge proponent of JUICE. Let's put it that way. It made our lives easier, like I said before. But I think that it can very well become a project if they don't start like leading it out a little bit left and right. That becomes an unmaintainable behemoth if it hasn't come to that point already.
Hmm.
And sometimes less is more, and I definitely believe that in programming, however hard it is to stick to that, um, less definitely is more,
Hmm.
until you need more, and even then it becomes quite a difficult thing to maintain. Um, I mean, I've seen so many projects tank because of their complexity, using too much memory and having managers for this and managers for that, managers upon managers upon managers. And I just don't believe in that way of coding. I believe in that if you want a cube on the screen, you're gonna write exactly what you need to have that cube on the screen. And if unless you have like an idea that is far beyond that, and you want that to work from the get-go, then of course, yeah, sure, go ahead and then create the abstractions you need, and create the code paths you need in addition to that, to get to the point where you want to be. But otherwise, just render the goddamn cube on the screen and be done with it, and then go figure out what's your next step. And I feel that some developers have a different approach
Yeah.
than that, and that they tend to engineer in a, yeah, more broad strokes way, and they tend to take into account scenarios that aren't necessarily relevant yet, or but sure, they are a lot. It's their good right to think that those are actual valid scenarios that are going to pop up. They can be very much right about that. So there are different schools of thought about programming in that way. But I tend to lean towards um, keeping things lean, and that's not something that I think JUCE does very well.
So you think so you lean more towards independence? Am I hearing that right when it comes to um, independence and modularity? Is that what you're saying?
Um, what I lean towards is I think best described as um, conservative programming, meaning that um, you make purpose-built software, both in what you make as software itself, but also when it comes to how you code things. You purpose-built them, and as long as there's no reason to write a class or a couple of lines of code or whatever, just don't write them, because it's, in my experience, it has like it enlarges your or to quote the Simpsons, it embiggens your chance of clutter and bugs and whatever, especially if there are cases left in your code that are never used, or it also doesn't make code easier to read. But then again, I mean, what I'm telling here right now is not an absolute truth in any kind of way. There are people who think differently about this, and there have been situations where I've also engineered things a little bit more intricate than I tend to do. But yeah, if I have one point of criticism on JUCE and certain other software projects that I can't tell you too much about, is that there's been too much being done on the drawing board and then executed in terms of code and subsequently never used. And that all results in a code base that is not necessarily more readable, not necessarily faster, and but you know, put someone from the other camp on the right of on the left of me, and there will be a lively discussion how I am probably wrong on some of my assumptions and vice versa.
Yeah, yeah, because what I hear, I imagine that, and I say this as a person who's managed and managing, um, large scale software projects, that there's always this battle of like modularity, reusability, scalability. Yeah, I imagine, especially for the JUCE team, it's like, okay, you go back to your example of a cube. It's like, okay, well, and all those considerations that you have with creating, let's say, a cube class. Is it going to be a 2D through cube? Okay, well, what a 2D, what if they want a 2D square rather than a 3D cube? And different considerations. What are what's the stroke of
I think you hit it on the nail right there. I mean, and that's why I completely see why certain software is written the way it is. Um, if you're gonna, and the cube is just purely analogy, yeah. But let's
I
just
mean, I'm just saying an example as well.
JUCE has definitely set some ambitious goals,
Yeah.
and they try the best, or try still the best they can to scale their code base along to reach these goals.
Mm.
Um, but if you just want some specific stuff, it's not necessarily the nicest code base to peruse when you're looking for answers. Whereas, and I fully accept that that's like uh, it's just it's let's just put it this way. It's easier when you know what you're gonna make roughly.
Yeah.
And when to translate this to the game world, for example, especially and when we're going back in time a little bit, if we're going to make a car racing game, you are going to make a code base that implements a car racing game. Whereas if we're looking at these days, and we still have a lot of games that work with their own proprietary engines and technology and stuff like that. But if we look at an engine like Unreal that, for example, is supposed to be able to do it all, much like Unity, to name one of them, or Godot. Then we have to do with a code base that's sort of like a meant to be a huge toolbox to be able to create a whole host of things. But that comes with a lot of drawbacks. And I'm not shitting on an Unreal Engine, for example, but having worked with it in a professional capacity for a while and a few times, um, a few of these drawbacks are definitely that there's like performance, there's some over engineering in the engine. There are even parts of the core engine that lead to nowhere because like someone started making it and it was never finished and it doesn't do anything. Build times for lighting data, sound data, level data, whatever you have, are bordering to the extreme at times, which is also, and then we come to number five, a reason why, especially studios that have money and have like enterprise kind of service license agreements with Unreal, they tend to modify the engine to yeah more or less fit their personal goals a little bit more, and even then it remains a challenge, and that's not because it's just a very hard problem to solve, right? You can't make one piece of software that can do everything unless you're willing to make some sacrifices. And I think that goes for audio or whatever you think of as well. And so
Even even
where
outside
I where
even
I
outside software development into life, right? It's like any anything, driving, playing an instrument, that you always have that trade-off of ease of use versus or the being able to set up something quickly versus manual control and that low level being able to make changes at a lower level. So I think you're right. It is that trade-off of can I get a slider on my screen, in under 10 seconds versus okay, what if I want my slider to be curved? What if I want my slider to be this unorthodox type of design, and that doesn't bend to the constraint? Because if you have a slider class, it's going to have some constraints, it's going to have some assumptions, isn't it?
yeah
And you can't escape that.
no
So
and so now that we're talking about it, I realize that maybe I'm like trying to bend things a little bit my way too much every now and then because I like simplicity. I like to know what I'm up against. But on the other hand, I really do respect the fact that some things just aren't that simple and require all kinds of abstraction and different kinds of implementation for like basically the same primitive. A slider class is a perfect example, like you just mentioned. Um, but on the other hand, it's a decision you have to make, and I think it's never going to be an easy one necessarily. Another problem with and this is a little bit of a pet peeve of mine, and some people who are listening, maybe who know me, are going to laugh their ass off when I mention this one. But for example, at a certain point, I was working at a company, and we were looking, for one reason or another, we were looking at the spread of a gunshot, and it looked awfully boxy. I was looking at the code, and eventually you end up in Unreal Engine's random generator classes. And these are well, quite engineered, and there are all kinds of different classes and functions, and you have what have you. But all of them, at least for Unreal Engine 4, I haven't double checked it in number 5, but they all tied into one call, which is the standard C rand call, the 16-bit one,
Yeah.
which has awful distribution.
Mm-hmm.
It's actually the C++ committee disencourages you to use it anymore. And I was like, all right, we need to change this right now and use like Merson Twister or whatever, anything that has and I know there are opponents of that as well because it isn't the fastest or anything. But then someone told me, have you ever thought about the implications of changing that one function might have? And that's something I didn't think about at that exact moment. And it's true. For example, there are tons of functions that are actually using that random facility that they built.
Mm-hmm.
So if you suddenly decide to change like what the output is of the random generator, how will that reflect on basically anything that's random, lighting, for example? Mm-hmm. You have no idea what the repercussions can be. And that also has that goes for engines like Unity and Unreal in games, but I think for JUCE as well, is that and any big software project basically that has a big user base, you can't just go and change certain core things because there might be dependencies that your customers have on that you can't change overnight. And that was a very good remark. I'm not sure. I would give credit to the person that made that remark at that point in time. I think it was a certain sir called Mikko Kalms, and I was like, yes,
Yeah.
that's absolutely true. And I was like really brash to offer the idea alone just to completely swap out that function in the engine itself, just not thinking about anything other than the problem that I was solving at that kind of point. And that's a weakness in like the simplicity way of thinking that I tend to have about these things. So in the end, like there was like a compromise being made in that I made yeah, our own random generator and our own place in the code base. But you see that what the problem can be as well is that like some things that might look stupid or antiquated or dated are there because it's just not that easy to change them anymore once the decision has been made.
Yeah, and you bring up a great point because this is a discussion that I see so much on the JUCE forum, for instance, where there are developers that wish that the code base and merge requests were more it was easier to get merge requests in, and that the code base itself was a little bit more open source. And it goes back to, it's very easy to build to code something up that works for your particular use case, but then when you throw it in the case, and I can't even imagine. I mean, I have so much respect for the JUCE team because the other thing is that this is not. I don't know if your particular situation, it sounded like a situation just within your own game studio. But imagine if you were the JUCE team themselves and you have to legacy support all of these products that are being built using your framework. And it's like a Jenga house, isn't it? It's like you pull a piece out, and like you said, you have no idea. Like you can see the apparent change that it's making in your specific use case, but you have no idea if that random call is tied into some sort of dependency that could be completely unrelated. Like you would never even think that those two things were connected. And for one reason, just because you changed that particular thing, it completely makes the rest of it collapse.
Yeah, you're absolutely right. And I didn't meant to say per se that like that we could, for example, even within our game studio ourselves, we couldn't really make a fair prediction of what changing that would actually have as a result. But yeah, if you're making an engine, and I worked for one of these companies for a little while, but you have to take into account constantly that like the lower level your change is, like the more exponentially the fallout of your change grows, both positively and negatively. And I've yeah, I respect that a whole lot, and that's why I said like I like building purpose-built simpler software because it's just easier, isn't it? It's more relaxed to do, and you know exactly what you're making, and yeah, it's just two different worlds in that way. But having said that, yeah, I think still, even though you can build complex software, I think, for example, what's his name again? John Carmack.
Uh,
I think that, and that's just a very specific example, of course, but at a certain point, he started releasing the source code to their games, actually quite early on as well. And who am I not to take a look? But for example, how he put together Doom 3 was to me quite enticing to see like how he tackled things, because he did like very much modularize things, and didn't overcomplicate them, even though the code base itself could do a million different things. But
uh,
they were not like they were not tied in together all that much. Like
mhm.
they had like a certain core, but apart from that, they were different modules that all used each other in order to build a product, which is in this case is the game.
Mhm.
And I think I remember being very charmed by how that was set up. And I do realize fully that that's a long while ago, of course.
Yeah.
But yeah, I think we've touched on the subject here in that if you're going to build something for general purpose use, and like for all kinds of, I mean, Unreal Engine, what is it used for? Simulation software, games, um, different types of, I think it's even used for CGI kind of stuff, and you name it. So yeah, they have to take a lot of things into account. But you know, it doesn't make it easier to work with necessarily as a programmer, especially if what you need is purpose-built software and um, performance that is dedicated to what you're making basically.
Mhm.
So yeah, you're basically shifting certain skills from left to right. Um, I think that's what it boils down to. And um,
What are your thoughts on testing?
not done enough.
Yeah.
And I am part of that problem, as in I find it all too easy to skip testing. But I'm a huge proponent of writing tests for a variety of different things. I think I can openly speak about how this was done at a company like Unity, for example,
Mhm.
um, years ago. Let's say you were on a team. I'm going to keep it a little bit abstract, of course, because I can't give away the exact details about it. But let's say you were on a team
Mhm.
and you made a feature, or you did some kind of change or whatever. Then you had to write a piece of accompanying code. Not all the time. I mean, exceptions were always made, and under stress and duress, certain decisions are yeah, hastily passed on. But okay, so then you had to write a test. Then that had to go into a part of the repository that belonged to your team, and that was tested. And then basically, it was three of those tiers, and it could take up to a month because if there was no certain pressure behind that kind of change or bug fix, it could take up to a month because before your change would show up in the main line or even longer. And uh, sure, at times that could be frustrating. And I believe that there's a middle way in everything, and that goes for testing as well. But especially as far as if your code base expands, um, it's just too easy to change something and to not to think much about it and to have shot yourself in the foot and to find out only half a year later, for example. I remember having written a little test a while ago for a completely small home project, but I was sampling a texture map in 2D using SIMD instructions. And I wrote a little test using a little XOR texture to see if like the output that I get for different sample coordinates was what I expected it to be. And I was happy that I did write that test because at a certain point I made a minor modification somewhere there and it screwed up and you couldn't see it until I ran the debug build and it ran the tests.
Uh-huh.
And otherwise, I never would have found out. So yeah, even in projects that aren't that large and are reasonably well contained, even hobby projects, yes, by all means, testing. The way you do it, I think, is completely up to whatever you prefer. I'm not
Uh-huh.
sure how you think about that, but
Yeah, I think that I used to think that it was something because we're all, yeah, all companies are running on limited resources, deadlines, all those things. And so part of me, I think, used to feel that we aren't writing life or death, you know, life critical type software for subway trains or, you know, for,
Mhm.
um, and that we could fix it quickly. But now, especially once you start getting into a larger code base, I'm finding that they need to be, it's almost essential now. You know, it's almost essential because like you were saying, with larger code bases, you have so much dependence that happens in between different systems that unless you have some sort of unit testing that's making sure that the output of your functions is valid, something could be happening in your system and you have no idea where the heck it came from. It could just come from anywhere. And if you have no visibility on what, you know, on what the valid outputs are supposed to be, then you're basically, you know, in a tunnel without a flashlight.
Yeah,
And it's and a lot of people, you know, a lot of people advocate it as well because it's documentation as well in a way, because it's like when you have tests, now you know what the outputs are supposed to be because the tests say that in the way the tests are written. So documentation, you know, another big problem as well in terms of larger code bases. But so now I'm thinking more of a balanced approach in terms of it's good to have visibility, especially on essential functions, essential classes, but that at the same time, I think that not every single freaking thing has to be unit tested because it just gets to be, you know, you'll have teams just writing unit tests, never actually getting around to doing development.
I think personally that the best way to approach it in many situations is that the tests that you have are better situated along the core set of functionality that you have. For let's say, for example, a vector class, or just to name something. And that's because they are at the core of everything, and any error that might come from that direction, even though the chance that there is that error is introduced once one of these classes has been written is smaller than it is like more upwards in your hierarchy. um it's more likely to show up. Having said that, especially in like high pressure environments, which I think most like critical software and multimedia software development is. I mean, we always have to have things done 1 month before, and you name it. But I think that yeah, testing is essential, but it's not being applied enough yet. But I think that we're still in a phase as an industry where we're trying to figure out like what's the best way to do this. I mean, if you're gonna write a small project in C or C++, you might as well just write your functions in C and C++ as well, you know.
Yeah.
Whereas if you have like a bigger system, where you're, for example, dealing with output that's being written to files, or certain compilation results that need to be checked, or logs that need to be scanned for certain error messages, you might want to pick a different language like Go or C Sharp or whatever to check these things. There are 1,000 ways to go about it, and that's what makes it hard for me to choose the right solution for that. But I definitely believe that um, yeah, like you said, with the rate that the complexity of the things we write is expanding, basically on a monthly basis almost. Testing is essential, and I think I should do more of it. I think we should all do more of it, but that's also, resource allocation, human resource allocation. We can't be writing tests and coding at the same time. At some companies, you would get it to a point where you'd almost like sometimes spend 2 days writing the testing code for a fix that you made in 5 minutes. And even though that feels counterproductive, I'm not sure if it is. I'm still like my jury is still not out on that one.
Yeah. I like what you said about that the closer to the core that you get, the more that you should consider testing. I think that sounds like a sensible approach. Makes sense. It's quite intuitive. Do you write your tests before you write your classes or after?
Yeah, that completely depends on the situations. I tend to let's say we're just referring to a class. I tend to design the class first. Like, what does it need to do? What kind of functionality does it need to implement? How does the interface look? Am I going to overload any operators? How are the functions going to be called? What data does it contain? Blah 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 blah. And then
Do you write that down on paper, or do you design it just in terms of like what the function calls are going to be, just super high level?
Well, not on paper, but in a code editor, just because I like to have a notepad beside me at all times, but I'm not going to write a complete class with by hand. I'm happy those school days are over, but I what I do usually is look at the interface and think, okay, so like what are the possible culprits here? What can go wrong, and what do I expect? And then I tend to write tests. The other way around doesn't feel very intuitive to me, because then you're like, what am I testing for?
Right.
And also another thing, it's not like I always am the one who gets to design the base class or the
Mm.
interface. I mean, especially when you work in larger teams and you work with technology that's already built or being built or in the progress of being built, there's always it's not always like it's more likely that it's not you who has designed the interface than it is.
Mhm.
So first of all, you start to implement it, and you're gonna, or I'm gonna look like, are there any tests implemented for this? And sometimes in some code bases, you're lucky there are, and they actually require you to implement that functionality in order for it to compile and work in the first place. So then you're lucky. But otherwise, yeah, otherwise you just have to see to check out like, all right, so what can be the possible pitfalls here, and where should I what should I test? You don't need to test anything, but I think a good strategy, if you don't really know, like you have an interface, but you don't really know which functions are essential to test, and simply make a diagram, like what calls what, and then you usually end up with a number of functions that define the core within the interface as it be. You start by, or I would start by implementing tests for the most core and base functions that there are within that interface, and then work upwards from there. Um, and I am still also a big believer in assertions.
Mhm. Yeah,
Like
yeah,
that's almost a religion for me.
yeah. I actually love assertions over tests. Just because, I mean, one, they're right inside the class. They're there to, they're quite quick to write as well. And they're one-liners, and yeah, I love assertions. They're great.
They do, however, and I've seen this in games a couple of times at least, suffer from code rot, just like comments do. That's why I prefer um, clear and well named, as in variable names and stuff like that, code over writing comments.
Mhm.
And also, when you're gonna write a comment, think why you're gonna write that comment. Is it
Mhm.
because your code ain't clear, or is it because you want to describe something that might already be obvious to
Right.
the avid reader? But having said that, assertions. One problem is that in some situations that I've experienced over time is that code bases have gotten slow to the point that a lot of developers, certainly developers that busy themselves with more high level problem solving, such as, let's say, something like gameplay or animation or whatever, they would seldomly run debug builds, and that would mean that not in all, but in certain situations, they would not trip assertions that normally would have been tripped, and that would result in, certainly in bigger teams, in situations where people were just like growing into the habit of skipping over assertions while starting something up or running something, like, oh, I've seen this one before, whatever, F5, go ahead. I've seen this happen too many
Yeah.
times. So there's no silver bullet when it comes to big projects, and it can be frustrating, but like, I understand it. But it doesn't stop me from writing tests nor assertions, especially assertions.
Mhm.
Whenever I write a function and there's something coming in, and I want to make sure that my code is able to handle whatever is coming in correctly, and there are certain domain constraints there, I will definitely always write an assertion,
Yeah.
knowing full well that 5 years later that assertion might not be valid anymore. It's just the same thing as a bug, really.
Yeah. Yeah. Um, what about your coding environment? What do you typically stick to the the Apple Console and Xcode? Do you use some type of other terminal substitute? Do you use C line, anything like that?
It very much depends on what the situation calls for. Of course, there's
Are
first
you
of
a
all,
Are you a Vim Ninja?
no, not really. I really do like, for example, editors like VS Code and Sublime,
Mm.
especially now that VS Code has a plethora of plugins, which makes it, for example, an ideal candidate to write C++ projects in that compile on OS X, because I don't like Xcode all that much. It's a matter of taste. Some do. Maybe I haven't spent enough time with it. That could be the case. But for like manageable C++ projects, I tend to go to VS Code. Then there's Sublime. I'm not a Vim ninja. No, not at all. I do use I do use the console, the terminal every now and then for this and that and the other. I am a satisfied user of a Visual Studio as
Mhm.
well. And then there's all kinds of middleware that I use, like Photoshop and um, Audacity and the Wise editor and you name it. I tend to use what I need, but when it comes to real these like things that people probably like for very good reasons, like Vim, like you offer. No, that's not really my thing. When I was a kid, I used to write software in edit.com in MS-DOS. I think that was archaic enough for me. No, I like a good editor, and I must say Xcode has its charms, but it's not my favorite. So on Mac, I'm a little bit yeah, I'm not quite sure what to use, but yeah, just what the situation calls for. I'm not religious about tools. It's like if it works well for the situation, then I'm more than happy to use it.
Yeah, I was a up until very recently, I was very much a purist. Apple, just the Apple console. Yeah, and felt like I just really need to learn um, learn my bash and just really get that foundation down well, and just using kind of the built-in tools. But lately, a friend of mine has been opening me up to some of the more modern tools. So now I've started using this tool called this terminal alternative called Warp, which is really cool. I'm really loving that. And it actually has it now has an AI. Um, it's a premium feature, but where you can actually, if you don't actually know the bash call, you can pull up an AI tab and say, you know, clone this repo, or push this upstream, and it'll
Oh,
actually come up with the it'll actually come up with the bash code for you, which is pretty cool.
that's excellent because if I may expand on that a little bit, or at least reflect, I remember, and this is I have worked with different kinds of environments, like for game consoles before, but my first real exposure to developing for Linux was maybe 10, 11 years ago. I had to write a relay server for media streams. This all had to do with well, a bug in Windows drivers back then that made us have a performance problem pulling in TCP media streams, UDP ones. So being completely out of options, so I was like, okay, let's install Ubuntu on a Linux machine and write a piece of C code that emulated the situation. And voila, I didn't have the same problem there. And we had customers waiting for us. So
Wow,
what
nice.
what I did eventually is I wrote a daemon
Uh,
and and that daemon would actually pull in the data, and it would through REST expose an interface so that our Windows software could request a certain stream from the daemon that would run on one of their Linux servers. And then it would just pull in the data UDP wise on Linux, and that would work with threadables, but let's not go into these details. But then again, it would turn that into a TCP connection with the Windows machine and just tunnel it through. Problem solved. But during those months that I had to write that thing, I think it was 2 months that I had in total to do it. I got to really appreciate the what's it called, the philosophy that was so different from for example developing for Windows, software for Windows, with the packages and all kinds of things in Linux that were a lot easier or like built in already to do, like log rotation and just to name something like that. It seemed to be much more tailor made for what I was making at that point in time, and I got to know like how to use bash and all those commands intimately. But to be honest with you, 5 years later I had forgotten at least half of it.
Yeah,
So,
yeah.
and like whenever you get to work with all kinds of different techniques throughout your career, it's just impossible to remember everything. So that's a good thing we have Google. It's a good thing we have AI. I know that there's like a big controversy with the whole AI stuff, but just to name an example, a while ago I needed in Photoshop you have these layers, and these layers have these different blend modes.
Mhm.
But if you don't have the Photoshop SDK, there's not really a good way of knowing what the exact formulas are for these different blend modes. So I just asked ChatGPT, what is this? How does that work? How does that work? And sure enough, the C code that rolled out of it was in no way optimal or whatever, but at least it told me, okay, so this is what actually is happening mathematically. And then I could take that and then implement it into my own rendering pipe. So I don't really get why people, some people, not all of them, but some people that I speak to every now and then are so hesitant or almost opposed to this technology, because just like you said, what you just offered there, Warp does it, right? Where you have the AI in, yeah, that's excellent, because if there's one reason for me not to use the terminals, it's because I'm like, oh, I forgot how that works. But if
Yeah.
I can ask the terminals, like, how again do I do this? Oh, thank you. Excellent, right?
I love it. I love it. It's got a load of other really cool stuff. I mean, just something even as simple as, in a terminal, you can't, even just being able to cut and paste and, copy things, or just being able to move your cursor to a certain place. Such a pain in the terminal.
Yeah.
Um, you want it to react like a regular kind of, modern text editor in a way. And yeah, so it's got all of that as well. Yeah, that's so funny. Yeah, like you said, if you don't, and what you were saying about AI, with Chat GPT, I mean, that's been my CMake buddy for a while now. Yeah, I've been working quite a bit with CMake lately, and getting libraries to come in, adding subdirectories, and um, that's been such a ChatGPT has been such a big help for me, with trying to untangle all of that. Yeah, it's very useful, and it'll actually comment the code output as well, which is really cool. It tells you exactly what each part is intended to do, and yeah, it's useful. I mean,
So it still
it
gets
won't.
it still gets it wrong half the time.
Yeah, yeah, it still gets it wrong, and also, people think that it's going to be a thing that'll replace software development in X amount of years. No way. I can't see it. Like you were saying, systems are getting more complex now. And with complexity, you have not just code complexity and dependency complexity, but also just version complexity of, you have, this certain version of Python running with this particular version of whatever. And for one reason, it doesn't build on Linux, Ubuntu, because of this thing, or that it needs to be that version of, it needs to be C++ 14 because we need to support a certain type of architecture that can only build on that using C++ 14. And with all of that complexity, I don't know. And that complexity just building, I don't see a day where, at least in the near future, where we'll be out of a job.
No, and I think the key word is context,
Yeah.
and context is something that in its current state, the AI is hard pressed to guess for you. And when it comes to something like I just offered about forgetting half what you knew about bash commands, or your linear algebra getting rusty, or your calculus, or your assembly instructions for whatever kind of processor. Whenever that gets me down, or I feel like I should have done a better job, or at remembering it, or I try to remember something a friend of mine told me a long time ago. It's not the information itself, it's that you know what you're looking for.
Right, right.
That's most important of all. And if an AI is able to help you by answering questions that you just kind of ask them verbatim, then all the better. And like you said, like I think one problem that or one thing that leads to some confusion when it comes to like for example, these days, even contracts saying that you can't use AI for implementing your solutions if you work for this and that client, or whatever. It comes from people in the past maybe having been idiots and feeding an AI like ChatGPT complete source files from their proprietary code base.
Yeah.
Maybe not realizing that then gets introduced into the collective mindset of that database that it's working off of. So yeah, you should use it with some care, but that's like the same thing of like that would be akin to going on Stack Overflow and saying, all right, here is our complete scene renderer for Resident Evil 6, and there's a bug here and there. Maybe one of you can figure out what the problem is. You don't do that either, right? So it boils down to common sense. But yeah, I'm very enthusiastic about AI, and I hope it can solve more and more and more. But I still think that, yeah, the day that we'll be out of a job as programmers, especially if you have some contextual knowledge about the low level and some experience, is well,
Yes.
we'll be on the golf course before that happens.
Yeah. Well, and it goes back to what you were saying, contextual knowledge, because in my experience, I always find that there's some exception to a rule. It was like what you were saying about using systems and frameworks that have larger abstractions, which is that there's something that comes up where you need something to do something different than what it conventionally does. You need the system to plug in a certain way for whatever particular reason, because one system needs to know a piece of data about this other system that, for whatever reason. And because of that, unless it has knowledge of the entire system, yeah, and I think that will be the future. Actually, I think it'll be smaller systems that have maybe particular domain knowledge about your system architecture that will maybe be able to reason more clearly about your particular situation. That's where I would like to. I'm sure that will be where it's going in the future. Rather than these huge. I think like the your average consumer will be cool with the large language models and everything like that. But I think for us as software developers, it'll be more very specific models that'll be trained and be knowledgeable about your specific system architecture and the layout of your code base, and be able to reason about that with a little bit more expertise.
I could see a situation, for example, and not a, maybe that's the case already. I haven't checked recently, but for example, Unreal Engine is kind of notorious for its lackluster documentation, to put it nicely.
Mm-hmm.
But I could see a situation where an AI solution would have knowledge over the entire code base. And instead of having documentation, you just go into there and you ask, like, all right, so I want to achieve this and this and that. You given these certain constraints, and then it will give you an answer like, all right, look at these classes and functions, and here's an example function how to do it. Might be much more effective than people maintaining documentation over a million or whatever, how many lines of code base, and B, it's much more effective than you searching through it. Isn't that true? So it might be a very suitable replacement for standard documentation to begin with.
Oh, I love that idea. That sounds
I
awesome.
mean, it would be great for JUCE as well.
Yeah,
And
it
if
would be fantastic for JUCE. I'm sure that there's something like that will be coming in the future, and that goes back to what you were saying. Naming convention. That's where things like naming conventions become, and having clear, just clear naming of your variables, of your class names becomes so much more important. It's like if you can get that down, that would be heaven. That would be utopia right there.
I mean, I used to take it. Sometimes I take it a little further, either in that I mean, compilers are smart enough these days. So let's say you have to calculate something that has a component of A, B, and C, and D is the product of A, B, and C. Now you could write one line of code that calculates all of that and just comes out with D ones at once. But I am more inclined to write const A is blah, const B is, and split it up that way. So it becomes more readable without adding any comments or something like that. I don't necessarily care a lot about code conventions. Instead, I do have my own preferences, of course, but I tend to not be religious about them. In fact, I think it's important that, let's say you step into a part of the code base, because right now when we're working on larger software projects, we've arrived at a point that there's not even a one kind of style within a code base. There are many, but let's say you're injecting or you're modifying code in a file that's been there for a while, and you're not gonna like change the notation there. I would say you adapt, because otherwise you're just messing it up. I used to think differently about that, especially when I was a lot younger. I actually did stupid things like, okay, so this function looks a little bit like I don't like to see it, so I'm going to write the function again, all bug proneness included. And I'm going to write it in the style that I like to see it. Oh, that was so stupid. Instead of just going like, okay, this person wrote it that way, and it would be more clear to everyone if I just kept that style at that point, to keep it within that context. But yeah, I think like, even if we're just like going back to something like Chat GPT, I mean, as long as people keep persist in asking JUCE related questions, which I'm pretty sure they do, we might not even be far off from the documentation being inferior to just asking ChatGPT. right?
Oh, yeah. I still have some room to grow in terms of what you were saying in terms of changing, taking a class, seeing it written or formatted in a way that is not your way, and changing it around or rewriting it. I'm notorious for that. As soon as I see something
If
that I
it's
think,
a mess,
yeah,
but what your perception of a mess is changes as well over time. But if it's a mess, then yeah, sometimes there's a point to be made to say, okay, let's just tidy this up, and especially if it's a one-off within a larger code base. But um, if it's something that's been there for a while, and especially that's something that multiple people work with, have worked with, etc., who are you to dictate that it should look different all of a sudden? And how is that going to make things better for everyone? No, there are many situations in which it doesn't, and in which I've learned to say, okay, um, I'll just adapt to how this looks. I might tidy it up a little bit, but I'm not going to change it stylistically completely because I feel it should be different. Because that's just my opinion of how it should look. And yeah, local consistency, I think, might be a way to describe what I'm trying to convey here.
yeah, that's a good way to follow.
I mean,
Cool.
yeah.
Yeah.
All right. I hate to be a party pooper, but it's getting kind of late here, and the little one.
Yes, it is. It is. And we've been on here for 2.5 hours. Awesome. Yeah, this is a great discussion. We said at the beginning we didn't know what direction this is going to go. I think this
We went off of audio quite quickly, actually.
yeah.
No, it's been my pleasure, and we could have gone on for another hour, I guess. But I got to be honest with you. I have some different things to do right now because we're in different time zones, obviously. I'll get back to you on LinkedIn, so I know how to prepare some stuff for next Tuesday.
Awesome.
And otherwise, yeah, thank you. It's been a pleasure talking to you. You taught me a couple of new things, and gave you some stuff to think about.
Yeah,
And
absolutely.
overall, yeah, thank you for the opportunity. I love
Yes.
it.
Thank you. Thank you for your time. A lot of amazing insights that I know other people are going to share those as well. So yeah, let's connect, and yeah, well, of course you'll be back on Tuesday. So let's connect before then and discuss.
All right. And in the meanwhile, keep it real.
Yeah, keep it real. That's right. Keep it real, keep it raw.
All
Have
right.
a
Bye
good one.
bye.
Take care. Bye.